Hello friends. Friends, today we will derive and discuss the derivation of a wave equation in a non-conducting medium in terms of electric field intensity E. So let us start with this discussion. Okay, now first let us understand the meaning of non-conducting medium. Okay, the non-conducting medium means which is non-conducting, through which there is no current is passing through it. Now, where is it possible? It is possible where there is no conduction current. So, first condition is there should be no conduction current because there are no charges. There are no charges. Suppose this is the medium. There may be charges at the surface, but within the medium, the charges are zero. So charge is zero, it means conduction current is zero, it means conductivity is zero. Now if conductivity is zero, that means J is equals to sigma E, conduction current density, it is zero. Okay, conduction current density I have discussed in my previous lectures. So J is equals to sigma E is equals to zero. Second thing is, if there are no charges, then volume charge density is zero. Okay, volume charge density is zero because rho is equals to dq by dv. If there are no charges within the medium, it means the volume charge density is zero. Now we have to apply these two conditions in Maxwell equations. In Maxwell equations, I have derived all the Maxwell equations. Now first Maxwell equation is del dot E equals to rho by epsilon naught. Second was del dot B equals to 0. Third was del cross E is equals to minus mu curly H by curly T. This is for the non-conducting medium. If it will be a free space, then there will be epsilon naught. So here we will write down not epsilon naught, we will write down rho by epsilon. Rho by epsilon. If there will be free space, then we can write down rho by epsilon naught. Okay, so minus mu curly H by curly T, and last one is del cross H equals to J plus epsilon curly E by curly T. So what are the conditions? Conditions is rho is equals to 0 and J is equals to 0. Okay, so this equation will become del dot E is equals to 0. This will become del dot H equals to 0 because B is equals to mu H, because B is equals to mu H, so del dot H equals to 0. This will remain as such. Del cross E is equals to minus mu curly H by curly T, and this will become del cross H. Now J is 0, so it will become curly E by curly T. Okay, I have derived all these Maxwell equations and summarized in my previous video lectures. Okay, in free space I have derived also these Maxwell equations, so I'm just rewriting those Maxwell equations here. So this equation is equation number 1a, this is 1b, this is 1c, now this is 1d. Okay, 4 Maxwell equation we have. Now take curl of third Maxwell equation, that is equation number 1c. Take curl of 1c. Okay, again I have discussed what is the meaning of curl in my previous lectures, so please see all the electromagnetic field playlist. Okay, so del cross E equals to minus mu d by dt del cross H. Okay, del cross H, this is our equation number 2. Okay, now apply a standard vector identity, that is del that is del cross E is equals to del of del dot E minus del square E. Okay, this is a proved result. You have to apply this result in equation number 2. Okay, so equation 2 left hand side will become del dot E minus del square E equals to minus mu d by dt del cross H. Now put equation 1a in above equation. Now what is equation 1a? Del dot E is equals to 0. So this will become 0. So you will left with minus del square E equals to minus mu d by dt del cross H. That d by dt del cross H. Okay. Now here what you can do, now put equation 1a, but you can also put now equation and equation 1d also. What was equation 1d? This is del cross H equals to epsilon curly E by curly T. So instead of this equation, you will get minus mu epsilon d by dt curly E by curly T. Minus cancel out. Now del square E equals to mu epsilon curly square E by curly T square. Now this is the wave equation in terms of electric field intensity E. Wave equation in terms of electric field intensity E. Remember, we have understood the meaning of Maxwell equations in our previous video lectures. Now to define a wave through a space, that space may be a non-conducting medium, a conducting medium, we must have a mathematical equation. Now this mathematical differential equation is used to define the wave equation in a non-conducting medium or in a lossless medium, okay, where there are no losses, or in a perfect dielectric medium, okay, perfect dielectric medium, same equation is used, or in a free space. Now in free space, only thing that will be changed is instead of mu and epsilon, we will have del square E equals to mu naught epsilon naught curly square E by curly T square in free space. And remember, free space is also a non-conducting medium. In our surroundings, it is a free space because the current is not passing through the free space. Otherwise, if there will be short circuit, suppose at a distance of 2 meters, okay, then the charges will flow and we will feel the shock. Okay, so it is a non-conducting medium. So this is all about the wave equation derivation. Remember these 4 Maxwell equation. Put these 2 conditions for electric field intensity. Put here this condition. Okay, take curl, then put equation 1a and 1d. Then you will get this result. Okay, try to solve in terms of magnetic field intensity H yourself. Otherwise I will discuss in my next video lecture. Thank you. Thanks a lot.